Morning all. Now we're going to do a bit of a walkthrough on using the Sliver framework to take over a machine. So I've got the Sliver GitHub page in front of you if anyone wants to know what the product is. But the reason I'm making this video is that everything I've read and seen in terms of tutorials on using Sliver talks about how to build your own stages, how to make your own custom executables, which is really great for many scenarios. Not as great if you want to target a particular user. Maybe if you wanted to do that sort of thing, a more likely scenario would be using a word macro, which is what we're going to do. So I've got over here what we call a Lua document. Now, I can promise you every business has someone who's going to be very happy to receive this Word document. And that's all a Lua document is. It's some rubbish you pulled out of Google that you might just email someone and they might just feel it's a legitimate document. So a bit of a side issue here, if I go to Save As and basically choose a type. So you'll note here, Word document, Microsoft by default will save a document as a docx format, which can't actually run malicious code. You can't put a macro in that. What you could do, you could call it a macro-enabled document, which is a docm. Basically, they split docx and .m so that they can very clearly identify something that might be malicious with macros. Docms typically won't get through mail filters, next-gen firewalls, things like that. Fortunately, if you go back a whopping 21 years, you can save it in the legacy format. And I'll call this malicious document because at one point in history, everything was just a .doc. And with a .doc, we can do anything we want. So let's come over now to our other virtual machine. This is the Sliver console that I've fired up, and this is what it looks like. I'm really a fan of Sliver because one of the things over some of the other options is the client-server architecture. The fact I can exit this client, reconnect from another machine, makes things very easy. So let's build ourselves a profile to run. First of all, let me just grab a command I've got for that. So what we've created now is basically just a listener and a profile. And this is something that you can run it's a server, basically, and you want to get on a victim's desktop a connection to this profile I've just created. Now, in a real-world scenario, instead of my IP address being a Hyper-V VM, it might be more likely, something I spooled up on a cheap VPS service, something like that. And now we're building a listener, which needs a different port. But basically what the listener is that Sliver will deliver, it's something that it's basically a web server that if you connect to it, it will give you a very convenient shellcode. And that ties into what I talked about. People go write executables that run that shellcode, which is usually quite handy, but again, not what we're doing today. What do we want to do instead to get something malicious in this document? Well, what I'm going to do, I'm going to go to the macros page and I'm going to do anything and it's going to go in this document and I'll just create something. Okay, apparently you can't call something any. I'm about to overwrite whatever I do, so there we go. So it's now in a place where it's happy to create a macro, and I've got a little bit of a template I'm going to paste right over the top of it. You can see here, it should be very obvious what this does. When you open this document via either document.open or auto-open, which I don't know why Office considers those two different things, but they are, it's going to run this string. It's going to run PowerShell, write host hello world. I'm hoping you know what that means, but let's actually go and do it just to make sure we have that working. So I'm going to hit save. So there's our original Lua document. You can see the malicious document has a slightly different macro, slightly different image, and the image does represent icon. Sorry, does represent that it's a different format. Now I'm going to hit enable content because let's be real, every average end user will. So that splashed up and it disappeared fairly quickly, but you will have seen that that PowerShell did run, which is what we want to do. So the next thing I'm going to do is I'm going to introduce you to just an interesting feature of PowerShell, right? In fact, let's do this here. So if I copy paste, this is the command that we just ran. So let's do that. You can see that basically, and not just means no profile, it means don't load user profile information, but you're basically saying, let's run with PowerShell this stuff. And that's particularly useful if instead of being in PowerShell like I am, you're in command.exe. Now, what if instead of one line, you had a whole lot of quite complicated code? Maybe it's multiple lines, it's got weird stuff you want to escape. You're stuck working out what to do with that. Well, there is actually something you can do about that. Let me go to a really great website here that's going to help with our encoding. So let's copy paste the command we've got as input into CyberChef. And we're going to run a text encode. Or is it encode text? Why? Because at one point in history, Windows actually decided UTF-16 was a thing rather than UTF-8 that everyone else currently runs. So we need to encode it accordingly, and then we'll do base 64. This gives us a string, and certainly for this one line that's very simple, this looks worse. But you can imagine if I had a huge script, being able to base 64 encode it makes things a lot easier. So E stands for dash encoded, and we've just run the exact same command now. And you can see it works as designed. That whole idea is where we're going with this, because if I was to get a shellcode loader in PowerShell, well, you're not going to run that very easily. So, well, not in a one-liner. So let's copy paste that. And look, I can't really take you through what this does because if you just Google PowerShell shellcode loader, there's examples all over the internet. They'll look a lot like this. All that's really specific to what we've written here is the URL that we're grabbing it from. And the whole thing now looks like this. So now what I'm going to do, I'm going to make a variable, it's base 64 equals this whole thing. And as you can see, antivirus software is being very difficult despite actually being disabled. Let me just kill that. Okay, so I've just had to load a new screen because despite having disabled Windows Defender before this, it came back. So let's go and, great, we've got a base 64. Now, in an ideal world, all I need to do is grab our macro and put our encoded text here. We can start it. We can start it with no profile -E and then the text. You would think that at this point we could just paste that base 64. The problem is Word macros, VBA in general, being a quite old and quite painful language, does not let you make a variable this long. So what we actually have, I've just got some nifty PowerShell that I've developed. It's a two-liner. It's going to split. Why did that paste that backwards? Let's paste that again. There we go. What you can do, even though you can't make one single line too long, is you can do that. And you can see here we've started with PowerShell, no profile, run this encoded, and what we're encoding is all of this, and then it's going to execute it. Let's save that. And we're going to quit. So we do have, in this situation, Windows Defender disabled on our machine. You can work harder to get around that, and that might be a later video. Let's open up, and you can see when I open Word, PowerShell opens. That's interesting. What happened here? Let's just wait a minute. So we've made a cut here, and the somewhat frustrating mistake we had made is that I had a 32-bit version of Office installed for some reason. That's part of my automated deployment because most installs of Office these days are 64-bit, and we had 64-bit shellcode. It's nothing to worry about other than you do need to think, is my client or machine likely to be older? If it is, we should have gone and generated 32-bit shellcode earlier. Regardless, let's go and open this malicious document. You can see here, nothing really came up. All looked fairly innocent. Someone's very happy to have this message. But let's go and open our Kali machine. And look, here we go. We've just had a session that's connected. So let's use that. You could have a whole botnet of 15 machines, all of which you control. Here we go. So we're using that. Now that we're using that, let's run a who am I. We are the victim. Let's run an ls. Now, being the victim, you do need to remember with Sliver, paths are forward-facing, or you can double escape them, but either way. Let's go look in our documents folder. You can see here they've got a spreadsheet called malicious or secret passwords. So we can actually use Sliver to download that. And that's now on my computer. And I can exit, and I can look at it, and I can do whatever I wanted with that. And when I'm ready, I can reconnect. My session's still running, and I've still got control of that victim. So I figure we'll wrap this up with one more thing we can do to take over our victim's machine, which is to grab their Chrome passwords. So you see here, I'm uploading Mimikatz, again using Sliver's upload functionality. Now that does start to kind of push what you could get away with on a machine with Windows Defender installed. As soon as something like Mimikatz exists, it's probably time to give up on being quiet or hidden, I would say. You're very reliant on a victim. But let's say we've got that. Now, something we can do is download this file, which I may have actually done in my history okay, so there's the user data, and you can see that there. That's just in the user's path. Now, if we download user data local state, which is a Chrome file, it's just a JSON file containing some data. Now, we can, if I cat that out, it's got a encrypted key in it, which you can see here. It's just one of the many things in that local state file. So using what we can do from that local state, we can execute the Mimikatz that we've uploaded. Now, we are not administrators, so we can't do things like dump everything from memory, scrape all sorts of stuff. but we can paste that encrypted key that you saw us get here and run it through Chrome. And look, we now have a user's Gmail password that's been grabbed by Sliver. Now, that was done entirely in memory from Sliver. Again, Mimikatz was dumped. That's a password that hopefully is extremely helpful to you.